All right, I'm going to be talking about essential optimization goals for mobile, how you can level up your game. This is going to allow you to have higher performing games on mobile, which will in turn enable higher fidelity content and allow you to run devices, run your content across a wider range of devices.
That's a big.
So let's take a deep look into mobile systems as a whole. So how are they different from desktop, console? Well, one thing is that they are a single system on a chip, which means that everything is stacked in one. So that's your CPU, your GPU, your flash. It's all stacked in a pile. Now this is great for efficiency, but this means you have all of the heat generating components in one place. So that's not so great for cooling, which leads into the second point that mobile devices are passively cooled. So you don't have fans even in high-end devices. You might have a heat pipe, but you don't have any fans, so it's all passive. So this leads into our power budget. Typically this is 3 to 6 watts. And this is because any higher than this, you're going to hit thermal throttling. And also any higher than this, the device is going to become physically uncomfortable to hold. And again, this varies based on climate. So in hotter countries, this could be less as well. So system thinking is really needed here. You're thermally constrained. You can't just run everything at max. You've got to fit things within a budget. So let's look into this a little more. So mobile devices are made up of a collection of CPUs, typically at least 8 cores, and they come in 2 to 3 types. The larger CPUs are for better single-threaded performance, and the smaller CPUs are more efficient for multi-threaded performance. The middle CPU is somewhere in between the two. Increasingly, we now see a system cache and a memory controller that interfaces with DRAM, and this is something to watch out for. The power consumption for a memory access is 18 milliwatts per gigabyte per second, approximately. And so whilst you might see in specs there are sort of 60 gigabyte per second performance, this is not sustainable. It's only for bursty workloads. So you can find even using 25 gig a second, that's half your power budget gone. So bandwidth is a massive constraint here. Looking at the GPU is highly parallelizable, but something that's different from console and PC is that we have a separate DPU, which is a display processor unit. This has real-time constraints, so something to watch out for here is that if it can't meet those constraints, it can fall back to the GPU. Now, frequency really matters. So if we take a look at this graph, you can see that you may be familiar with this on PC if you're familiar with overclocking. You can spend quite a bit more power for a little bit more performance in terms of frequency. But the good thing for mobile is that because this curve is non-linear, it works the other way. So that means that if we underclock, we can use significantly less power for only a little bit less frequency. So this is what you're going to want to do to fit within your power budget. Bandwidth, on the other hand, is a different matter. So let's take a look at this graph. This graph shows sort of over the last 10 years approximately how the energy cost has changed for operations. So you can see logic has come right down. It's over a 10x improvement, so logic has become a lot cheaper. Bandwidth, on the other hand, has progressed much slower. It's only improved by 1.7 times. So you can see why proportionately it's become much more important to optimize for bandwidth. This is really going to be your bottleneck. So this is a quote from Peter Drucker that I think sums up the approach that you should take well. And it's efficiency is doing things right, effectiveness is doing the right things. Now, what does this actually mean? Well, often we find that studios will spend time optimizing the smaller details, things such as shaders, things within the game already. But what you need to do first is take a step back and look at your process as a whole before you even worry about these sort of things. So let's take a look about how we can put this into practice. So if we start with effectiveness, the first thing you're going to want to think about is using an appropriate base config. So this is what resolution are you targeting? 720, 1080, 1440? What frame rate are you targeting? 30, 60? Now it's important to note, making the wrong choice here is already going to set you up to fail, because going from something like 720 to 30 to 1080 to 60, that's 4 times more work. So you need to really think about this. You also need to think about things such as what color formats you're going to use, things like that. And obviously, you've got to think about these things across the devices you want to target as well, because the answers are going to be different in a high-end device to a low-end device. Once you've made these decisions, then you start thinking about your algorithms, making use of appropriate algorithms, so making sure things fit within your performance frame budget. Think about your lighting, your shading, Make sure your engine that you're using is making use of multi-threading, because multi-threading is really important on mobile. And then the next thing is to avoid redundant rendering. So you can do things quickly, but the quickest thing to do is just not to do it at all. So have a think about the draw order to reduce overdraw, make use of good software culling to do as little work as possible on the device. And once you've done these sort of overarching decisions, then you start to worry about the smaller details, which is efficiency. So what are these things? So these things such as minimizing your model data. So think about triangle count, vertex count, things like that. You know, have a look at your scene. Maybe you don't need a super high-res model if it's right at the back of the scene, things like that. Once you've done that, think about texture data. Again, this is similar. You don't need a really high resolution texture if it's not going to be that visible. You can also make use of things such as texture compression, and that can help massively in terms of bandwidth. As we've seen, that was really expensive. And then optimizing your shader code is the last thing you should worry about, which often people make the mistake of doing this first. Now, it is useful, but it's not as useful as these other things. And this is mainly just doing things to make the compiler's life easier. And that's sort of a quick overview of how I think you should approach this. So I'm going to put up some links now. So we've got a couple of links here if you want to snap a picture. The one on the left is just great mobile game development resources. We've got deep dive guides, tools, things like that. And the one on the right is a link to our free suite of tools on Performance Studio. So these are a free suite of tools that allow you to optimize your games. You can download and try them today. We've also got demos of these tools and more in the booths behind us. So after these talks, feel free to jump around there and have a look, and we'll answer any questions as well. And thanks for listening. Let me go to the next slide. Yeah, you've got my email there as well if you want to contact me. My colleague is going to be coming up here shortly with another talk, and we're going to show you a live demonstration around how you can make your devices more secure in terms of memory access. So if you stick around, that'll be on shortly. But thank you for coming.
Thank you. Great.